Hello everyone, myself Venkat Mohit. I am pursuing my BTech in CMR University. Today we are going to learn about pointers. When declaring a variable, the compiler sets aside memory storage with a unique address to store that variable. The compiler associates that address with the variable's name. When the program uses the variable name, it automatically accesses a proper memory location. No need to concern which address, but we can manipulate the memory address by using pointers. Let's say we declare a variable name and rate of type integer and assign an initial value as follows: int and rate equals to 10. The variable is stored at specific memory address and can be depicted as follows. The variable scope is local to the main function. The memory allocation is from the main function's stack. The end rate memory address is a number so can be treated like any other number in C. Using modulus P, the address is in hexadecimal format. Hence, if a variable's memory address is known, we can create a second variable for storing the memory address. From the previous example, let's declare another variable named pt_onRate to hold the address of endRate variable. At the beginning, pt_onRate is uninitialized, so storage has been allocated for pt_onRate, but its initial value is undetermined as shown below. Let's store the endRate's memory address in pt_onRate variable. So pt_onRate now holds the endRate's memory address where the actual is stored. Finally, in C vocabulary, pt_onRate is pointing to endRate or is set a pointer to endRate and can be illustrated as follows. So the pointer variable declaration becomes something like this: int pt_onRate. In other words, the pt_onRate variable holds the memory address of endRate and is therefore a pointer to endRate. The asterisk is used to show that is it the pointer variable instead of normal variable. Now we are going to see the definition of pointer. A pointer is a variable that holds memory address of another variable where actual data is stored. By using pointers, it is an efficient way of accessing and manipulating data. Very useful for dynamic memory management. As we know, memory, registers and cache are scarce resource in computer system. Every computer system there are fixed and limited amount of memory for temporary data storage and processing. There are loading and unloading data into and from moving data from and to different location of the memory, including the cache and the processors registers for temporary data storage and processing. The loading and unloading need an efficient memory management. Some of the memory portion also used for shared data to further optimize that utilization. This shared data access depends heavily on the pointer's manipulation. Without moving, loading, unloading data to from different locations in memory, we can use pointers to point to different locations. Pointers are simple variables. A pointer is a numeric variable and like other variables must be declared and initialized but before it can be used. The following is a general form of declaring a pointer variable. For example, char chname int n type of char float f value. Type of stored data is any valid pointer based type such as char int float or other valid C derived types such as array and struct. It indicates the type of the variable's data to which the pointer is pointed to. The pointer variable name follows the same rules as other C variable naming convention and must be unique. From the pointer declaration, example, in the first line, the declaration tells us the chname is a pointer to a variable of type char. The asterisk is called indirection operator and it indicates that chname is a pointer to type char and not a normal variable of type char. Note the position of the asterisk. It is valid for all the three positions. Pointers can be declared along with non-pointer variable as shown below. Once a pointer is declared, we must initialize it. This makes the pointer pointing to something. Don't make it point to nothing. It is dangerous. Uninitialized pointers will not cause a compiler error, but using an uninitialized pointer could result in unpredictable and potentially disastrous outcomes. Until pointer holds an address of a variable, it isn't useful. C uses two pointers operators. Indirection operator, asterisk symbol, has been explained previously. Address of operator, ampersand symbol means return the address of. When ampersand operator is placed before the name of a variable, it will return the memory address of the variable instead of stored data. How ptrdiff type can be used to return the subtraction operation between two pointers. It is a base signed integer type of C or C++ language. The type's size is chosen so that it could store the maximum size of the theoretically possible array of any type. On a 32-bit system, ptrdiff will make 32 bits on a 64-bit on 164 bits. The ptrdiff type enable you to write well portable code. ptrdiff together with wchar and size t defined in stdef.h. The comparison is valid only between pointers that point to the same array. The following relations operators work for pointer operation. A lower array element, that is those having a smaller subscript, always have a lower address than the higher array elements. Thus, if p pointer 1 and p pointer 2 pointing to the elements on the same array, the following comparison is true. P pointer 1 is lesser than p pointer 2. If p pointer 1 points to an earlier member of the array than p pointer 2 does. Many arithmetic operations that can be performed with regular variables, such as multiplication and division, do not work with pointers and will generate errors in C. The following table summarizes pointer operations. Here are the operations and description. And first, assignment operator. You can assign a value to a pointer. The value should be an address with the address of point operator or from a pointer constant. Second, indirection operator. The indirection operator gives the value stored in the pointer to location. Third, address of point operator. You can use the address of operator to find the address of a pointer, so you can use pointers to pointers. Incrementing operator. You can add an integer to a pointer to point to a different memory location. Differencing, you can subtract an integer by a pointer to point to a different memory location. Comparison operator, valid only with two pointers that point to the same array. Let's say we have declared a pointer something like this: int iptr_var. This statement declares a pointer to type int but not yet initialized, so it doesn't point to anything known value. Then consider the following pointer assignment statement. A special relationship exists between pointers and arrays. An array name without brackets is a pointer to the array's first element. So, if a program declared an array char chname is 10, so chname is the address of the first array element and is equivalent to the expression, which is the reference to the address of the array's first element. Chname equivalent to ampersand chname of 0. The array's name is therefore a pointer to the array's first element and therefore to the string, if any. A pointer is a constant which cannot be changed and remains fixed for the duration of program execution. Many string operation is C uh, sorry in C are typically performed by using pointers because strings tend to be accessed in a strictly sequential manner. Here is the example of the program on pointer and array. Pointers may be arrayed like any other data type. For example, a pointer array IArrayPtr of size 20 is declared as to assign the address of an integer variable called IntVar to the first element of the array. We could write something like this. To find the value stored in IntVar, we could write something like this: IArrayPtr of 0. To pass an array of pointers to a function, we simply call the function with the array's name without any index or subscript, because this is an automatically a pointer to the first element of the array as explained before. For example, to pass the array name IArrayPtr to viewArray function, we use the following statement. Then we can refer to the individual string by using pto char pointer. of 0, PTO char pointer of 1, and generally this is identical to declaring char asterisk pt char pointer, or from last figure char double asterisk pto char pointer. Thus, programs that accept arguments true command line, the main function parameter list is declared as follows: int main function of int argument char of double asterisk argv. On something like this, where the argument counter and argument vector are equivalent to pto char and pto char point respectively. For example, programs that accept command line arguments such as echo. This can be illustrated as given below arguments. So our main function now has its own argument. As a convention, these are the only arguments main accepts. Notice that the argument vector is an application name. Argument counter is the number of arguments which we input including the program name. Argument vector is an array of strings holding each command line argument including the program name, that is the first array element argument vector of 0. But some implementation will have another third parameter, envp or env, which is a pointer to an environment variable as shown below. Environment variable is operating system is an array of strings. Null pointer constant. The null pointer constant is guaranteed not to a point to any real object. You can assign it to any pointer variable since it has type void. The preferred way to write a null pointer constant is with null. Char asterisk p null pointer equals to null, or char asterisk p null pointer equals to null pointer. Null pointer when set actually pointing to memory address 0 into 0000000 32 bits. The computer system have reserved this 0 address for null pointer, and that is why it cannot be used for other purposes. In C++.NET programming, null pointer is used as the keyword instead of null. Since C functions can only return one variable, it is common practice for those which return a pointer in set to null can avoid the strip pointer. Set a pointer to null to indicate that it's no longer in use. And other pointers declarations that you may find and can make you confused are listed below. And something to remember, asterisk is a pointer to, square brackets is an array of, brackets is a function returning, ampersand is an address of. Thank you to one and all.